Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Codes, DTC P2251-16 and P2252 are related to the air-fuel ratio, AF, sensor 1, detecting a low voltage in its VS, voltage signal circuit. When the AF sensor's control system identifies that the VS circuit is shorted to ground, it triggers the powertrain control module, PCM, to store these codes. This indicates a problem in the sensor's functionality, meaning it might not be providing accurate data to the PCM, which ultimately affects engine performance. The AF sensor plays a crucial role in managing the fuel-air mixture, ensuring optimal combustion and reducing emissions. Located typically in the exhaust stream, its failure can lead to increased fuel consumption and elevated exhaust emissions. Understanding the intricacies of these codes is vital for effective troubleshooting and ensures that the vehicle maintains performance standards. The AF sensor 1, is responsible for measuring the air-fuel mixture in the exhaust gases, which helps the PCM determine how much fuel to inject for optimal combustion. The Control Application-Specific Integrated Circuit, ASIC, within the sensor interprets the signals and communicates with the PCM. When a short-to-ground condition occurs in the voltage signal circuit, it triggers a malfunction notification to the PCM. This means that the expected voltage levels are not achieved, leading to abnormal readings from the sensor. Commonly located in the exhaust header or manifold area, if damaged or malfunctioning, it could severely impact engine efficiency and emissions. Consequently, identifying and fixing this issue is essential for the overall health of the vehicle's engine system. The diagnosis of DTC P2251-16 and P2252 indicates several possible causes of the low voltage issue in the VS circuit. One prominent cause could be a shorted wire within the circuit, which can occur from wear, corrosion, or damage to the wire insulation. Another potential reason is a failure in the AF sensor 1 itself. Sensors over time can experience degradation of performance, often due to environmental exposure and age. Lastly, a malfunctioning PCM could also lead to issues, especially if it's unable to interpret the sensor signals correctly. Each of these components has distinct functions and interdependencies. Therefore, accurately diagnosing the fault among them is essential for effective repairs. When DTC P2251-16 and P2252 are triggered, the most immediate symptom is usually the activation of the check engine light, CEL, on the vehicle's dashboard. This is a warning indication that the onboard diagnostic system has detected an issue that needs attention. Additionally, the vehicle may exhibit poor fuel economy, as the incorrect air-fuel mixture can lead to inefficient combustion. This could be noticeable in the vehicle's mileage and fuel consumption patterns over time. Furthermore, rough engine performance might also be observed, characterized by unstable idle or loss of power during acceleration. These symptoms stem directly from the malfunctioning AF sensor not providing accurate data to the PCM, necessitating prompt diagnosis and repair. The first troubleshooting step involves inspecting the external circuit associated with the AF sensor. This includes examining the wiring harness for any signs of damage, frays, or wear that could facilitate a short-to-ground condition. It's important to carefully check each wire in the voltage signal circuit, looking for any points of contact that may be shorts. Additionally, verifying continuity through a multimeter is crucial. The readings should reflect normal resistance. If any wires are found to be shorted, they will need to be repaired or replaced before further diagnosis can occur. Any existing faults in this circuit can lead to erroneous signals affecting the PCM's ability to manage the engine's air-fuel mixture. The next step is to inspect the AF sensor, sensor 1, itself. This involves removing the sensor from its location in the exhaust system and inspecting it for physical damage or deterioration. Since there is no direct method for testing this sensor's functionality, employing a known good AF sensor is a best practice. By swapping in a functional component, you can test whether the issue replicates or resolves. If the failure does recur with the tested sensor, it likely indicates issues with other components or circuit paths. However, if replacing the sensor solves the immediate problem, it confirms that the original AF sensor was indeed faulty and required replacement for proper vehicle function. If the previous inspections have yielded normal results, it narrows down the issue potentially to the PCM itself. Thus, a thorough examination of the PCM is required, as this central electronic unit processes signals from various sensors, including the AF sensor. If other inspection items are functioning correctly, any irregularities may lie within the PCM's internal system. Testing may include checking for proper voltage outputs and communication signals to ensure there are no malfunctions. Identifying any troublesome components or performance issues is crucial, as the PCM's failure can lead to widespread engine management problems if not addressed promptly. After any repairs or component replacements associated with DTC P2251-16, resetting the PCM is an essential step. This involves disconnecting the battery or using a diagnostic tool to clear any stored codes. Following the reset, start the engine and hold the RPM at 3000 without load, ensuring the radiator fan engages as expected. Then, allow the vehicle to idle and monitor for any reappearance of DTCs. This verification process ensures the repairs conducted were effective and that the problem has truly been resolved. Continuously monitoring for issues post-repair confirms the integrity of the repair work and maintains optimal vehicle performance. Implementing preventive maintenance strategies can significantly reduce the risk of DTC P2251-16 reoccurrence. Regular inspections of the AF sensor and associated wiring should be part of standard vehicle maintenance. Ensuring the sensor and its connections are free from debris, moisture, and corrosion can extend component lifespan. Additionally, timely replacements of aging sensors are crucial given their exposure to harsh conditions over time. Awareness of potential environmental damage to wiring and connectors also aids in maintaining the integrity of the voltage signal circuit. Adopting a proactive maintenance routine can enhance vehicle performance and reliability. In conclusion, understanding DTC P2251-16 and P2252 is critical for effective vehicle maintenance and repair. These codes directly relate to the air-fuel ratio sensor's performance and its signaling to the PCM. By following the laid-out diagnostic procedures and troubleshooting steps, mechanics can identify the source of the problem efficiently. Additionally, conducting thorough repairs and preventive maintenance can help prevent future occurrences of these codes. Ultimately, maintaining the AF sensor's functionality and overall engine performance is essential for achieving optimal vehicle operation and compliance with emissions regulations. Please like and subscribe to the channel. See you next time.